Well, that will be an interesting talk for me because usually I'm doing a technical demos, and usually I have a computer and I'm showing stuff live, and that will be different. So hopefully it's the right track and you will follow. And I think it will be really good though. So you're a customer, and every customer today in the ecosystem is trying to do some transformation journey. And most of them, the one I talk to, with no exception, is starting with migration, right? The problem of we all have a monolithic application. This is kind of like an old-style application. We really want to move to microservices that will give us a lot of benefit. They're all trying to do that, and not easily, right? But once they're actually going to do that, they will discover that like everything in our ecosystem, what we're doing is that we're solving one problem, but we're introducing a lot of new problems because the way we solve it. So that's exactly what you discover when you move to microservices. Because suddenly, simple stuff like communication inside your infrastructure is going to be a little bit more complicated because now you need to explain or to create actually two microservices, and you need to make sure that they'll be able to communicate to each other. You need to make sure that they're doing it securely, of course. And you're also trying to figure out what the heck is going on in all these microservices environment. So for that, you're probably going to use something like Service Mesh. That's exactly the problem that Service Mesh is trying to adopt. But what Service Mesh is doing something more interesting. It's actually the way we actually implement Service Mesh, it's actually abstraction on your network. And if we actually abstract your network, there is way more stuff that we can do. And in that case, I think that a lot of the health of your application can come with that. So let's kind of like now dig to all of this and understand what you're doing. Now, at my company, Solo.io, we're actually doing a lot of stuff with migration. We have our own API gateway called Glue that's focusing on that, but I'm not going, this is not a vendor talk, so I'm not going to talk about that at all. If you want, go check it out. But let's understand what the problem that we're doing. So as I said, when we actually, introducing microservices, there is a huge improvement that we just created, right? I mean, productivity, people are going so much faster. I can push so much code in the same day, and immediately it's in production. The design is forced me to be right? All these two pizza team. You have to make a small piece of code that's relevant to a specific subject. You encapsulate your code very well. You make it very flexible. I don't care which language you use, which technology, which protocol. It's just going to work, which is pretty awesome. But of course, we introduce a new problem. So now everything is in the network. And network is a complicated stuff. So that means that now go figure out the dependency. There is a performance, always latency in network, right? How do you figure out where is the problem? It's inside the code. It's inside the pipe. Where is the problem? Cost, of course. I mean, now figure out. You need to change all your tooling. Nothing is going to work anymore. Now everything is distributed all over the place. And also testing. Go figure out how to test something like that is spread around. So that's basically the problem that we're dealing with right now. You have one monolithic application. It's pretty simple. Let's take a use case for something like debugging. I'm just attaching a debugger and see what's going on in the application. But now I have more application, and the code is spread all over the round. So all the stage of my application is actually spread around. And then we discovered that there's way more than 6 microservices that I showed in the previous slide. This is what some companies like Netflix and Twitter is running today. We're over 500 microservices. So it's way, way more complicated. Now try to make all of those to communicate. That's like, oh, wow. And then you see something like that in Twitter, right? People are sitting and they're very confused. How the hell do we debug that right now? How do you actually finding out what to do with this? And then now your stack is different, right? Before you had monolithic application, you're using something like APM for the metrics, for logging maybe Splunk. It's just an example, right? I don't know. Native debugger is something that you will use to debug. Today we're not debugging anymore, we're troubleshooting. Architecture will be something like service-oriented architecture. Deployment will be something like Chef, Puppet, Ansible. Maybe you will build it with Terraform. And testing, it will be 80% unit test and only 20% integration. But now it's all done, different, right? You will use something like Prometheus, because now you need load and scale, and you need to manage to handle all of this. And then when you're looking at, something like logging, now your logging is spread all over around. You have a replica. How do you know where to collect them and to make sense? So for that, you need some transactional logging. You need to put some idea in this and then make sense of it. That's something like OpenTelemetry or OpenTracing was before. You're not debugging anymore. That's not what we're doing in microservices anymore. One of the things that we did in my company is created an orchestrator for debugger in order to make that actually possible. Microservices is your infrastructure, is your architecture, and you will use something like Elm, for instance, or any other development specification, and now it's all about the integration, because that's all what you're running right now. So again, you have this great monolithic application, now microservices, now the network is the piece that is very problematic. The question that I asked before, how do you actually make sure that they're communicated? How do you make sure that they're doing it security? And how do you make sure that you can actually see what's going on inside the cluster is the big three problem that everybody's trying to solve. And they do. It's called service mesh. So again, what is service mesh? Service mesh is basically solving that exactly three problem. In terms of security, it's giving you root certificate, MTLS between the microservices policy, making sure that everything is really secure. In terms of routing, again, it's using proxy as a sidecar, and it's basically making sure that you will handle all the routing and communication between them. And in terms of the observability, he knows because of his special architecture, he can actually spin off the log to a location and the metrics to make sure that you will see better. OK, so again, a little bit I will explain how it works just to really kind of like level out everybody. We have a service. We're putting what's called a sidecar. Sidecar is basically a proxy. In that case, it's Envoy coming from the Lyft guy, open source project in the CNCF. And what it's doing, it's pretty dumb, right? It doesn't know what to do much. The only thing that we're doing is we're tricking the application, or in this case, microservices, that every communication to the application and from the application, we're playing some with the IP table, is going to go through this proxy. So it's basically everything is going through him. And now you need to give him configuration because, as I said, it's pretty dumb. He know how to do the stuff. Someone needs to tell him what to do. And therefore, you need some control plane. You probably will need one. Oops. You probably will need one in the API gateway. That's something that's coming outside the cluster. You want to be more secure. And you will need something in the service mesh, and again, control plane to give them because it's different if something comes outside your cluster and something is already inside. So it's looking like this. You have a cluster. There's a lot of microservices. You need to take care of the traffic that's coming not to southward call. And that's basically everything that's coming to your cluster. And then you need to take care of and that will be the proxy that is on the edge. And they will get here from the API control plane the information. And besides that, you need to take care of the east-west. And for that, you're going to put a proxy next to every service. And you will have a control plane of service mesh that actually will tell them who allowed to talk to who, what is the root certificate of them, and so on. So there's going to be a lot of doing done by that. And now every traffic that's coming here, it's done by the proxy that getting configuration from the API gateway. And every traffic that's inside the cluster is managed by the sidecar. OK, so that's great. So right now, hopefully everybody understands what is service mesh. Again, I'm a big fan of this technology. And apparently, I'm not the only one, because that's everything that everybody's talking about in 2019, right? It's like service mesh is going to be the future. It's going to renovate everything that we need. It's going to solve a lot of problems, and therefore, everybody want to get a turn to play. So the first one that came there is Linkerd. Linkerd came from the Buoyant guy. It's a startup. The first version that they did was horrible. The sidecar, we like to call it the side bus because it was so big, was very bad Java implementation. But then STO, the Google guy, said, well, that's nice, very important to fix, but to be fair, it's just bad, so we're going to create our own version. They took Envoy as the sidecar. Linkerd tried to fight. They created their own option, better implementation. Console Connect, which from the Ashi guys came. They really want to focus on security, and so on and so on. And of course, any cloud that respects himself will be available, including AWS. So now I'm Mr. Customer, really excited about the opportunity of the service mesh. Which one am I going to pick? What is the difference? Who is the best? That's a good question. So what people are doing, or most of my customers are doing, they're exploring. They don't know. So they're starting with STO. They're looking, they're playing, they're taking a team, they're learning the technology. 3 months later, they discover it's too hard. Because it is. It's really, really complicated. So they're going to move to Linkerd. they will decide that it's pretty simple and working. But here's the thing. It's not using Envoy as a sidecar. And Envoy becoming this important and commodity proxy in this ecosystem. There's huge community around it. We are contributor as well to Envoy. And therefore, we're going way faster for them. So again, they don't want to bet on this. So they will go with Consul. They discovered that Consul didn't even do layer 7 yet. And everything about service mesh is to bring those networks to the layer of the application, layer 7. So again, I don't know if it's interesting too much. So they will move to app mesh and so on. And in the end of the day, a year came by. They're not implementing a service mesh, which is really a shame. So we thought about how we can help them. And the way I thought is, what if they're only going to need to learn one API? What if the technology behind it will be just technology? We don't care, right? It's just going to do what I'm expecting him to do. And instead of being so complicated like STO, because STO coming from Google engineers, they have to use edge cases that are happening in the Google infrastructure. Most of the people doesn't have that problem in their infrastructure. So what if we can come with this abstraction layer that will make it easy? First of all, at least they don't need to learn all those technology. They only need to learn one. Now, of course, by the way, that's the big cloud, but then companies like Kong and other that in API gateway, they have to play there, right? Because they make it very uncomfortable for them, so everybody is a mesh right now. They're not really a mesh, but they're a mesh. So the point is that in the end of the day, we need to abstract it. We need to make it way simpler to work, and we need to make sure that we are not locked into provider, because who knows we will win here? We've been here before in the Kubernetes war, right? It was Kubernetes and DockerCon, and Docker Swarm and Mesos. Who do we know who will win? So that's basically what we thought that we should have done. And we did it. And lucky us, Microsoft agreed. And Microsoft is a great company, and it's a big company, not like us, small one. So they managed actively to get all the community around it, and we basically launched it together. We call it Service Mesh Interface. And what Service Mesh Interface making you, again, it's an open source project, it's the community project. It's basically giving you the ability to use whatever service mesh you want, but one interface for that. And this interface, it's simple. The adapter know how to communicate, so it doesn't really matter which one you're using. You can start right now. It's also make it way simpler. So the beautiful of Microsoft is that they can actually make something like that happen, right? We can write the code, but they need someone to actually be able to go and influence HashiCorp to help, and go into influence Buoyant to help, and bring all of us together, or Reddit and all the guys, basically make sure that as a community we can build something like that. OK, so we have this thing, this interface, and we have all those service mesh, and we can actually use it. It's pretty awesome. But there is something more interesting in service mesh, and that's the way it's actually working. So service mesh is not solving only 3 problems. That's what's happening today. But think about what's special about how we build it. Before that, back on the day, we wrote code. In the code, we put operation code. Example, security, routing. You want to put your log, you need to put some library. You want to do chaos engineering, you put library. Everything is imported in library. Now, if your provider is upgrade this library, guess what? You need to have a new version for your microservices, even though you didn't change the code even. So the question is that the right way to do it? And of course not. And like everywhere, the best way to do it is actually decouple. And that's exactly what we did here in Service Mesh. Basically, what we're saying, the sidecar's responsibility is to be in charge of this operation. That's their job. And the business logic of the microservice need to be the business logic. And that could be an application team that's writing it. They don't need to talk to the operation. It should be differently. And now we're bringing back the power to the operation, which I think should be there, right? This is why those people so experienced and need to be there. So if we're doing this, there's way more we can do. And that's what I think is special. This is why we needed this interface, because we want to put stuff on top of it, right? And because this is like, service mesh will become commodity. But I want to start and innovate before this thing is settled. And for that, I need some place that I can actually count on it being there. And this is this interface. So what can we put there? So of course, API gateway, right? I mean, in the end of the day, the full solution, like I show, should be the service mesh that will take care of the communication between inside the cluster, but you also need an API gateway. And that's very important. And they need seamlessly to work together. And they need to understand each other and be aware of each other. And that's one thing that we need to do. The second thing is that we have a lot of ideas of what we can do. I can give you an example of something that we built, which is basically an ability. We did it together with Lyft. It's basically the ability to record every request that's coming to your infrastructure. And because it's going through those sidecar, we can actually record it but we don't have to use the ones that are good. Now, think about it. It means that if it's going to the database, if it's going to the S3, all this communication in and out, we can record. If we can record, in the end of the transaction, if everything good, we're not going to use it. We're just going to toss it, right? We don't care about everything that is good. But if something is wrong, we can actually take it, the recorder, and then spin it up outside the production, inject everything that was in production, and replay any bug that was there. This is an example of project that we did with Lyft. So there's a lot of stuff that we can do, and I believe that the customers themselves should do, internally implementation. Again, you have these things, it's giving you a lot of power, use it. So if you think about what are we doing here, right? What is my vision for that? My vision for it is like iPhone or Android, right? In the end of the day, it's an iPhone, right? It's a platform. And in the platform, you're getting a lot of stuff. You're getting whatever, discoverability and a lot of other stuff, and this is what you're getting. But you're also getting some application by basic. And those applications, like for instance, your calendar or your email, you're just getting them. I think that we should get those two building blocks, which is API gateway and service mesh, because that's the building block to abstract your network. So now, like an iPhone, if you have this ability to do this, I think what's powerful about the iPhone is the fact that two applications can communicate to each other, right? Like I'm putting a calendar invite, and it's already talking to my Google map. That's one thing. And the second thing is that it can be extendable by the App Store, and that's exactly what we should do, right? We can just put something like chaos engineering on top of it and not put the library inside your code. You know why? Because you can just inject it on the proxy. You can inject latency. You can inject, you can inject forms, whatever you want. You have the ability to do that right now. The power is in your hand. And something like, in that case, canary deployment. You want to make sure that the new version is working well. Be smart about it. Put traffic shifting and so on. So we'll show you a quick demo. Usually I'm doing live, but now it will be this. This is something called a Service Mesh Hub. It's free. It's online. If you go into servicemeshhub.io, this is what my company did. But basically, again, it's open source, so you can look at it. It's based on our work. Basically, what you can see here that I have two service meshes. One of them is a service mesh from AWS App Mesh. And then the other one is Linkerd. And there is the extension that we could actually, hopefully that will work, yeah. And then I can install another service mesh, something simple like STO. And the only thing that I need to give is the namespace and which version I want, and it's just going to work. Very, very simple. So this is the basic one that I need in my infrastructure, right? I'm choosing a platform, and click on this, and in a second you will see, boom, you have the service meshes installed. So now you have STO. It's already discovered everything, all the services that it's managing, all the configuration. It's smart about it. And the reason it should be smart is because I want it to be able to actually go now and install an extension of it. And the extension can be something like Kiali from Red Hat, which is, again, open source. It's giving me visibility on the cluster. It could be something like an API gateway, like ours, Glue, or others. It could be something like Canary deployment, like Flagger from WeWork, and so on. So the idea is, there is community that's working on top of it. We can give you everything you want because you're going to use Service Mesh. So, I will go, hopefully, I don't know if I can move it fast. And we'll go next. But basically, as you can see here, Kiali is installed right now as an extension. I can go and install others. And you can put your own extension. We can actually collaborate as a community. In a second, it will finish. I don't know that I can with my clicker to move it, so I'm sorry about that. It will take only a sec. And that's basically the idea. If I would do next, do you think it will work? Oh, yeah, it's worked. OK, so what next? OK, so it's talking about this future. It is a future for a lot of people. But actually, there's a lot of people running it in production. This is the future. It's something that it's worth exploring. But it's like every new technology, there is a lot of gap. We solve those problems. Here's the new one to adapt. So here's some example one. Service mesh is really, really hard to configure. This is a tweet for some of the guys, Sebastian, who basically said, you thought Kubernetes is hard to do? Now try to do with STO. Good luck. And he's right. It's hard. Now, I think that the Service Mesh Hub will help you with a lot of stuff. The SMI will help you with a lot of stuff because we make it simpler already as a community. But we can do more. When you actually install Service Mesh to the, when you're installing, for instance, you wanted to install whatever, something in Docker, you're not starting from scratch. When you're installing service mesh, the configuration is starting from scratch. So we can take advantage for some experience from Docker and basically come with the bundles of configuration that the community will share between each other. And then what I can say, I want this service mesh, I want those extensions, I want this configuration. And then I can tweak it. But it's already built layers that way that I will be able to get close enough to where I need, and I don't need to start from the beginning. I think that would be very powerful. And the last, so stay tuned. We're working on it, and it's really close. And I believe that it will be eventually a plugin for CI/CD system. The second thing is that, OK, so this is great. I have this amazing technology in my infrastructure. No problem, right? The application developer is actually going to develop these things, and then he will do this. This is an example for configuration, YAML configuration that you need in a very simple, it's called the bookstore. It's the demo application for STO. It's the basic one, right? It's really basic. So what you can see here, you need to create a repository from STO that actually has configuration for all of this. And then I just click, for example, on the networking. You need to do more YAML file. So all of this is YAML file. Now we're becoming, that's all we're doing. We're basically dealing with tons of YAML file and trying to configure that. Do we really expect the application owner right now to actually understand service mesh with all this mesh? No. Why did we do that? We did it in order not to take this power from them. So the question is what we can do there. And again, we're working on it. I think it will be very interesting. So, I mean, hopefully it was interesting. My name is Idit. Go check everything that we, that own service mesh is out there. I'm Idit. I'm the founder and the CEO of a company called Solo.io. And go check the resource. I think you will find a lot of cool stuff. Thanks so much.
Thanks, Idit. That was interesting. And as someone who's been talking about proxies and the power of a proxy and all the cool things you could do at the proxy and how the proxy is the right place to add a ton of value that you don't want in your application and your business logic, it's kind of slightly warming to my heart to see this sort of proxies making their way down into the microservice space. But it is hard, you're right. Yeah. And I think as I was listening to you talk and listening to Tara talk and listening to Nell talk, there's a couple of things that have to happen, I think, to take all this amazing potential and technology to be applicable to everyone, to be applicable to kind of the people that don't have 1,000 engineers on tap. And I think we need to get our organizational and our mindset and our community space and the way we work with each other inside organizations together. And then we need tools like this to take away the complexity. We have to be able to operate this stuff without, 1,000 PhDs lying around, because there's tons of companies out there that just can't recruit that kind of talent. We're not all Google and we're not all these people. So really, really interesting talk to hear how these come together. We do have time for questions, if anyone would like to ask one. If not, I have a couple more questions. No. Cool, okay.
So maybe I was very clear, or I just lost everybody.
No, I think it was certainly clear to me, and I'm hard of understanding quite a lot of the time. So one thing I wanted to ask is where do you see the line being drawn of what you put in the sidecar proxy layer and what you put in your application? What's the logical kind of boundary point? What should I never put in my app, and what should I always have in my
Yes, I mean, everything we can move to that sidecar. The beautiful about the sidecar is that it's configurable. There's no code involved. It's YAML, so it's easier in a point. And therefore, everything that we should put there, besides the really business logic of the application, what it's doing, that's specifically to what it's trying to achieve, and nothing that related to how it's communicated or how the logs is going to work or how to troubleshoot. That's all operation, and that should be in the sidecar. It should be configurable, because then it's easy to change, and you don't need to create a new version for it and redeploy that. It's just configurable. That's, I think, the power of the proxy.
Now I'm going to ask a totally unfair question.
Yeah.
So we saw all the players in service mesh.
Yeah.
Who's going to win?
I don't know. I mean, it's a good question. I think that STO has Google behind them, and they're making a lot of marketing noise. But I think they need to work on their implementation, because it's a mess right now. They're getting to the right place, so hopefully it will take them. So I will bet on them, even though who knows.
Excellent. Thank you very much. Any questions? Oh, everyone's hungry for lunch. OK, so thank you so much for your time.
Thanks so much, guys, for having me.